Okay, this video starts out with equality of sets, and just when do we call two sets equal? So suppose we have these two sets, A and B. In math, we say they're the same set, they're equal. You know, they have different names, but they're the same set. So we write A equals B, like that, in mathematics. Okay, now this one is much easier than the ones before, because we can use a package, or rather a package that's in R, and we can just use the set equal function. Just means are these equal? So let's try it. Suppose A equals this, and then C is just the same, but we put the cat dog at the beginning. I don't know if I'd say just the same, but suppose we do that. Okay, first, let's look at this. A equals C. So this is the equals operator in R. Notice this is not the equals operator in R. This is the assignment operator. This takes what's on the right and assigns it to what's on the left. So because this is the assignment operator, or one of them, actually it's not the official one, but it serves as an assignment operator, we need a different operator for equals, and this is the equals operator. Now if you ask if something is equal to something else, you expect it to be either true or false. In other words, you expect the answer to be a Boolean. Now, but this doesn't work quite the way we want, because I want to ask whether A is equal to C, but if I try it, I get this. So what is it doing? What is this equals operator doing? It checks element by element to see, is the first element of A equal to the first element of C? The answer is no. Is the second element of A, which would be 2, equal to the second element of C? The answer is no. So it does it element by element. So there are 10 elements here, so there are 10 falses here. So we could use this and then wrap this inside of an any statement. But let's not do it that way, because you can also do it this way. In other words, there's already a function called set equal, means are the sets equal, or are these two things equal as sets, I should say. And if I test that, A and C, I get true. So even though they're not the same vectors, but as sets, they're equal, and this works for that. So we don't have to write one, it's already there. And let's see how it works with, suppose we write D is this A, and then tack on an extra element there, NA, and we say, are these equal as sets? We get false, which probably is what we want. We probably wouldn't want to say that D is the same as A, because D has an extra NA there. So we probably don't want that. So this is probably good for what we want. If we wanted to call them equal, we could rewrite or create a new function, but at the moment I don't think we'll need that. Okay, let's also talk about the empty set. So the set with no elements is called the empty set, and I think at the beginning we said the set of all dogs with the IQ of 200, greater than 200, is probably the empty set. And we need to be aware of this in our code, this concept of the empty set. If we make a specification on a set of variables, and that specification is like over-specified, meaning that there are no elements that satisfy it, then the result is going to be like an empty set. And then we might not have been aware that we might get an empty set. So our code may fail unless we remember that this is a possibility. So that may occur, and deal with it in our code. So it's just kind of a precaution. I'm not sure when this would come up, but it might come up. So anyway, this is the concept of empty set. Okay, let's stop this video and then we'll come back to subsets. And also we'll come back to intersection and union and complement. But let's come back to those in the next video.